Physics Part 91. Label each force with its magnitude with a small symbol if you do not know the magnitude. For each force you must know the cause of the force, gravity, friction, and so on. And you must also know on what object that force acts and by what objects it is exerted. This label diagram is referred as a free body diagram because it detaches the body from the others in the situation. Having established all the forces acting on the body, you can use Newton's second law to find unknown quantities. This procedure is illustrated in the example which follows. Newton's second law equates the resultant force acting on a body to the product of its mass and its acceleration. In some problems, the system of the bodies is in equilibrium. They are at rest or moving in a straight line with uniform speed. In this case, the acceleration is zero, so the resultant force is also zero. In other cases, the resultant force is not zero and the objects in the system are accelerated. For whichever case applies, you should remember that forces are vectors. You will probably have to resolve the forces into two components at right angles and then apply the second law to each set of components separately. Problems can often be simplified by making a good choice of direction for resolution. You will end up with a set of equations based on the application of Newton's second law, which must be solved to determine the unknown quantity. Example: a box of mass 5.0 kilograms is pulled along a horizontal floor by a force P of 25 Newton, applied at an angle of 20 degrees to the horizontal. A frictional force F of 20 Newton acts parallel to the flow. Calculate the acceleration of the box. A free body diagram is shown in the figure, resolving the forces parallel to the flow. The component of the pulling force acting to the left is 25 cos 20 is equal to 23.5 Newton. The frictional force acting to the right is 20 Newton. The resultant force to the left is thus 23.5 minus 20 is equal to 3.5 Newton. By Newton's second law, E, F by m is equal to 3.5 by 5.0, 0.70 ms. Now it's your turn. A gardener pushes a blunt mounder of mass 18 kg at a constant speed. To do this requires a force P of 80 Newton directed along the handle, which is at an angle of 40 degrees to the horizontal. A. Calculate the horizontal retarding force F on the mower. B. If the retarding force were constant, what force applied along the handle would accelerate the mower from rest to 1.2 meter per second and in 2 seconds. We've got the section summary. The force of friction opposes motion. The Newton's law of motion defines force. The laws are: first law, every body continues in state of rest or of uniform motion in a straight line unless acted upon by a factor, by a force.